Hello everybody, back at the Mioty Alliance booth here in the Embedded 2022. I have with me Svein Vetti from TI. Hi Svein.
Hello. So as you said, my name is Svein Vetti. I work in the TI Sub-Gigahertz business unit. We're located in Oslo. We work with radio ICs and I'm involved in finding new products. So small integrated circuits that can perform radio applications around the radio.
Alright, so TI was one of the founding members, but we had discussions with the other interview guests, like the reasons why and mioty in general. So today we want to talk about a quite serious and significant topic, which is low power. And low power in the meaning of an infrastructure and an ecosystem means operational freedom. So, why is mioty better towards the low power than the other LP1 technologies?
Yeah, I would say that there are multiple reasons why mioty is a good solution for low power. First of all, it's a kind of radio technology itself. So the way they split up the packet in smaller chunks of data and transmits them over different times and different frequencies, and that makes it easier for a kind of battery to recover. So you can use smaller batteries and they will last actually longer. Another thing also, there is lower overheads in the packet, so you're basically sending less waste in the ether with mioty than compatible technologies. So that's also a really important thing. So mioty is the lowest LPWAN technology there is.
So in the consequence, mioty enables the end user and of course also the device to really use the available battery power in a very sufficient and sustainable way. So what kind of battery lifetime is possible with the mioty power solution?
Yeah, so we have customers today that can show for more than 10 years of battery lifetime. So I think that's quite exceptional. So you can really maybe even extend beyond that. Then we start talking about battery chemistry and if the battery actually can handle it. But mioty can really offer more than 10 years of battery lifetime for sensors. So
we talked about end user freedom and we talked about why low power. So can you refer to some ultra low power applications?
So what we see today, that's kind of an already existing market where and maybe those people are maybe the world champions in terms of low power, and that is flow meter manufacturers. Those are existing products today that actually does quite a lot of things. They measure the flow, they transmit the radio, they keep track of a lot of stuff, a lot of track of time, and those products will last for 10, 15 years. So those are the kind of products on the market today that is really the longest battery lifetime products there is.
Okay, can you name some the growth of the ultra low power applications? Is there any trend?
I think there are a lot of other products applications that can kind of benefit from the same technology that the flow meter guys have been doing. So I'm thinking maybe it could be industrial sensors that measure slow moving things like temperature and pressure. It could be agriculture sensors that measure moisture or something in the soil, also things that moves quite suddenly. So you can have a solution that sleeps for a long time and then wakes up and transmits something useful.
If you look at the radio frequency system on your chip, what are the parameters which are really significant for the performance? And for example, which can enhance the battery lifetime?
So the most important thing it's to be able to sleep or go to standby when it's referred to. That means that you basically do nothing, but you keep track of time and then you retain your memory. So this is called standby consumption. Because this means that you can go to sleep or standby and you can keep your memory and then you can wake up at certain time intervals, do your measurements and then transmit again. That is the most important thing. And it's also important that is also low power, also over higher temperatures. And that's something our products is quite unique doing. So we can maintain a really low current consumption also when it's a bit hot. it's in an environment where the temperature is high and maybe you're exposed to direct sunlight. So that is really important.
So that means the battery lifetime and the power consumption goes in line with high temperatures. Is that so?
Well, I think higher temperature is even more challenging. Our parts can do that very well. So also over higher temperatures we can maintain this low standby consumption. And the number that you're looking for there is about 1 microamp. So 1,000th of a milliamp, while it's just keeping the memory and keeping track of time, so you can wake up at certain time intervals and get your data on the internet.
Being, of course, in the applications myself, the other extreme is, of course, colder temperature. I know we haven't really discussed this before, but do you have any opinion about, now we talked about the high temperatures, how about the low temperatures?
Yeah, I think from a silicon point of view, lower temperature is easier because you have less leakage, you have less consumption actually. So then I think the lower temperature is more, the challenge there is more the battery technology, that you kind of have a slower chemistry or maybe higher internal resistance and things like that. So it's certainly not easy, but from a silicon point of view, actually lower temperatures is actually easier, but not from a battery point of view.
All right, looking to an ecosystem and looking to the sensors itself, there are also some sophisticated sensors which also the customers really like to integrate into their ecosystem. So how about low power with high sophisticated sensors? Does this go along?
Yeah, that's even more challenging. So the problem with that is that you have to wake up and do something. So a microcontroller has to do some number crunching. So in our parts we have a dedicated sensor controller, a dedicated sensor subsystem that can execute at very low power. So we can also do those applications, or many of those. So it's kind of the easier thing is to kind of just sleep for a very long time. It's much more difficult if you have to do something, if you have to wake up and process those sensors. But we also have capabilities there, and we can do the processing and also at the same time offer a very long battery lifetime.
Wow, that's even new for me, because usually if you have the sophisticated sensors getting back to life in the older days was basically drawing battery dramatically. So you also have solutions to counteract in that one. Wow. So we talked about your solutions, and we talked about availability of these solutions in the low power. So we know you have a lot of products, and so for a quick start, what's your recommendation for a development kit?
Yeah, so we have some small sensors. Actually, I forgot them over there. So we have some kits.
Take the microphone. I knew you would not come with empty hands. So here we go.
Yeah, so we have some really cool kits like this. It's called LPSDK. So these guys has a radio, antennas, and everything you need. Also has a bunch of sensors. So this is a really good starting point for starting your mioty network and doing some applications that you measure something. There's also accelerometer here that you can use, temperature sensor, light sensor, some other stuff as well. So this is a really low cost. It's like a $40 thing. It's only been radio certified, so you can actually use that as a product if you like. Yeah, this is a really good kit to start with. LPSDK. Just go on the ti.com webpage and you'll find it there.
Here you go. You don't have to really search for plenty of sensors and put them together. Here you have everything in one package, and I know it from experience myself. So a lot of applications you can really handle with this unit, and then basically go into how should I say, mass installation of the application. What was the name again?
It's LPSTK.
So LPSTK is the way to go. So if you want to have multiple sensor signals in one comprehensive box, that's the thing to go. Check out the TI website, and yeah, if you have questions, we will find you, Vetti.
Just contact us on the webpage.
All right, so then nothing can go wrong here. We are all safe and covered. Thank you so much. Thank you so much for taking the time. Last word to say?
Thanks a lot for being here. It's great, and go ahead and make your own mioty product.
Well, I hope that the next shows are not going to end up with our startup, that we have a 2-year basically interruption in between. So I'm looking forward to see you and see the new products of TI. Very thrilled. Thanks a lot. Thank you.